Hello everyone. So today we will make a short video about how to connect your ABB drives to WinCC SCADA system without using a PLC. I mean, we could directly connect the WinCC SCADA directly to the drive using the OPC. So if you didn't know, the ABB Drive Composer Pro, it comes with the OPC server. So you can see the OPC server configuration here. So I'll be using my Ethernet communication to communicate with the OPC server. So if you are using a USB cable, you can select the others. So let's connect. So you can see my DC voltage is already coming. Okay. So now I will close this uh, and I'll show you how to configure the SCADA system to connect to the drives OPC. So I'll be using TIA portal to create the SCADA. So let's create a new project. Okay, then add new device. So here you can see the HMI. Sorry, here schematic HMI application. And I'll be using this. Okay, so your schematic PC station with WinCC RT Advanced SCADA system. So if you go here, you can configure your tags, connection, then screens. Okay, so first we will go with the connection, how we are going to connect with the device. So click this. So here you have option to add connection. So you'll click this. Okay, so here you can define how you are going to connect to the device. So for me, I'm using my OPC connection to connect to the OPC server of ABB drives. Okay, so let's click OPC. Then you can click your local server. Okay, so here you will find all the OPC servers that is installed in your laptop. So I have many, but depends on what all you have installed. So let's connect to the ABB drive. So double click on this. Okay, so now the connection is made through OPC. Through local server you are connecting to your ABB drive. Okay, so now the connection part is done. Now let's create some tags. Tags means the variables or the data types that you are going to connect to your SCADA system from your drive. Okay, so click on add new table. Click this. So here you can click add new. You can give some name. For example, I'm going to take my DC bus voltage. So let's define this as a DC bus voltage. Okay. So don't this no need to change right now, because when you define the address, it automatically takes the data type. Okay. So go here. Sorry. Uh, Click here. Click the connection. So this is the connection you made right now. See, if you go to the connection, Our connection name is connection 1, or let's make us ABB CS 880 drive. Okay, so let's go back to the tags. So here you can call your connection, that is the ABB CS 880. Okay, so here you can define the from where you are going to read the value. For example, I am reading DC bus voltage. So click there, you have the ABB drive, and you make sure your drive is connected. Okay, so click here, go to parameters, actual values. So here I am going to take the DC bus voltage. Okay, so there you have it. So we have connected the parameter link to our drive, and it automatically takes the data type, and we are getting the DC bus voltage. Now let's add some more, like motor current, then speed feedback. Okay, so again you define where you are going to read the value. So we are going to read motor current. Okay, and speed feedback. Motor speed used. Okay, so now we need to call this tags to your screen. So you can create a new screen here. Okay, so we will click the toolbox. Now we will use this. Okay, now let's define the tag. So I'll be using this to show the value of my DC bus voltage. So here you can define your tag. So your tag is from tag table DC bus voltage. Okay, so my DC bus voltage is configured. I can give a name. Name. Yeah. DC bus voltage. Okay, now let's define motor current. I'll copy this. Okay, motor current. Change your text. And this will be your speed feedback. Now let's configure this as speed feedback. Okay, so now your screen configuration is done. Now we can directly run it and see if you can see the DC bus voltage will be coming, because motor current and speed feedback will come once you start the drive. Okay, okay, so I have my DC bus voltage coming. Okay, now if you want a now this is getting updated every 1 second. So if you want a more fast update, you can configure it in your tag. You can go back to your tag. So here you have something called as a acquisition cycle. So if you need a fast acquisition, you can change to 100 millisecond motor current. Good. Okay. Now let's say you want to start the drive from here, from your SCADA without PLC. So this is purely experimental. Use this only if you have only if you are doing like a simulation test kit or something. I don't think it can be used in a real site situation. Just to show you that even this is possible, I am just showing you how I do it. So this is again purely experimental. You can find your own method how to start the drive from here. So I will show you how I found a method to do it. So you can create your start button. Start. Then we'll call a button called stop. Now we will go back to the dry composer. Open your dry composer. So I already explained the basic parameter setting of the drive in one of my videos. So after doing the basic parameters, you have this start stop direction. Okay, you need to change this to in one. In one means it will take the command from here. Okay. Now you can see there is a parameter called data storage. Here you can define any values as you like, and you can use these values to connect to the parameters on the drive. So I'll be using integer 16-bit. Okay, uh, let's make it 0 and let's give this value 50. I'll explain why I'm doing this. Okay, now on the drive you have something called as adaptive programming. Okay, click on adaptive programming, and here you have the edit program. So you can create your own logic what you create in the PLC on the drive itself. Okay, so I'll show you a method to start the drive. Delete this. Greater than. Okay, and here you can connect your parameters. Okay, so click on parameter value, give the name as 47.21, and this we will keep it as a constant. Let's define 15. Okay, and here I can give the direct start command, external one command. Okay, so what happens is like when I give a value above 15 in 47.21, I can get a start command. Okay, you can define any value. This is just for this, again as I told you, is purely experimental. You can try any method you like. Now run the program. Okay, now your adaptive program is running. So as you can see, if the value in 47.21 parameter is greater than 15, it will give a start command. Let's try that. Okay, let me give a value. Let me give 20. Okay, see, my drive is started. You can see the motor current. My drive is started. Okay, so if I give a value less than 15, my drive is going to stop. Yes, the drive stopped. The next thing, you need to give a speed reference. Okay, so how you can do is like, so now to give a speed reference, I'll be using this one, uh, this variable 47.1 to give my speed reference. It should be a 32-bit. That's why I configured here. If you see, this is a 16-bit. So let's give the value, the speed from here. Now you need to tell the drive that you are going to take the speed reference from this parameter. So go to your speed reference selection. Okay. Now you select this reference one source. Click other and go to 47. 47.1. See, the I gave 50 RPM, so it came 50. So now if I give a start command, the drive will run in 50% speed. So I'll change this value above 15, make it 20. So my drive is running in 50 RPM. Okay. So now if I can make a SCADA program to do this, means I will be writing 20 to start the drive from my SCADA, and I'll be writing 10 to stop the drive from my SCADA, and I'll be giving directly the speed reference 47.1 from my SCADA system. So we will try that. Now let's close this, then open your SCADA system. Now let's configure the tags again. So as I said, my start command will be 47.21. Okay, now my speed reference. Speed reference will be 47.1. Okay. Now go back to your screen. So now when I press start button, I should give the value 20 to my 47.21 parameter. That is, I configured this as a start. I named my parameter as a start. So when I press stop, I should give value 10. So in order to do that, you can write a small script here. Here, you can add your new script. Okay. So let's name the script as start command. Okay. Now here you can press Ctrl J. So this is your start. Okay. Equal to 20. So if I call this, run the script, it will give the value 20 to this start. Okay, now let's create a one more script called stop. Okay, now let's give value 10. Okay, now I need to call the script while I press the button. Okay, so click on start, click on this. Okay, the events, when you click, you can call the start function, start command. Okay, similarly for stop, when you click, you can call the stop command. Okay, so this will give 20, this will give 10. Now we need to give our speed reference, so use this speed reference. Okay, so now our SCADA program is ready to run the drive from SCADA. Let's try that. Okay, so I'll give a start command. Yes, so my drive is running and it's giving a speed feedback. Now let's give the feedback from here. Let's say 200 rpm. Yes, the drive is moving to 200 rpm. Now let's give a negative rpm, negative 500. Yes, and if I want to stop this, I can give the stop command. Okay, so this is a like an experimental method how you can start and stop the drive. Now if you uh, you can try your own methods. I mean, there could be some better method, you could try that. And I will also show you how I have made this more safe. I'll show you that. I'll open the program that I have made before. So this is the adaptive program that I have made to make it more safe. This again, you can try different method. So here I have made a timer to give a heartbeat kind of thing, like it will change the value from 1 to 2. Then I will use my SCADA to receive that heartbeat signal and send it back to drive. Then here I will be checking if my, so this way will create a heartbeat and you will receive the heartbeat, and here you will check, this logic will check if the heartbeat is missing more than 2 seconds, then it will automatically give a stop command. So this is basically my start command, and these blocks are for getting the status word signal. Like 611 is your status word, first bit, then second bit, third bit, then this is your reset, fault reset command. Now I'll show you the SCADA system for this. So this is the SCADA system which I made, and this is DC bus voltage, and this is the heartbeat that I am receiving. Heartbeat is nothing but that timer value change from 1 to 2. Then I will be sending 1 to 3 to the drive. This is my motor current, and this is the start stop value. For example, if I give start, this will change to 20. If I give stop, this will change to 10. And the fault reset, speed reference, speed feedback. Okay, now let's give a start command. Okay, now my drive has started. So if I give the speed reference, the speed feedback will be coming. So you can see the status word signal here: ready for on, ready for run, ready reference. Okay, so you need to make a better script for giving the to consider safety situation, like if the connection breaks between from your SCADA to drive, it should immediately stop. All these things you can make intelligent logic to do this. So I am using this heartbeat to do that. So when I press stop, you can also see my speed reference will go to 0. This is again I'm doing with the script only. See, the speed reference went to 0, and my script will not allow to change this. So all this you can do some intelligent logic in your scripts. Okay, so I hope this thing was interesting. Like, as I said, it's purely experimental. You can play with it and make your own better things. So my only intention was to show you that this is possible. Hope you like it. So thanks for seeing this video. Thank you.